Now we will shift over to Apostolos Tsolakis from the Delta Project, I believe. And let me make you presenter.
Hello.
Hi.
From my side as well.
Perfect. Thanks. All set. Thanks.
Good morning. First of all, I would like to thank Zia and ATM for organizing this very interesting workshop and very good opportunity to check the work, the very interesting work from other projects as well. And I will briefly present on behalf of the Delta Consortium and CERTH AI, which is the project coordinator, a little bit about our project. Here you can see some information about Delta in general. We are a 3-year project with 10 partners from 8 countries all around Europe. And the objective is to tackle the challenging aspects of the changing in the energy landscape, presenting some added value tools, mainly for aggregators and other market stakeholders, targeting mainly the exploitation of the untapped flexibility of small and medium customers through a novel security management toolkit. We want to facilitate aggregators to take decisions and distribute demand response requests. We would like to engage consumers by presenting more friendly and interesting tools like gamified services or collaborative platforms. And of course, since we are also delivering both hardware and software solutions, we are really interested in presenting an interoperable end-to-end solution. Through the project, of course, new business models as well as recommendation for policymakers are expected to accelerate market adoption. Here you can see more specifically the impact as we see it. We want to connect various stakeholders, distributors, aggregators, retailers, and various end users. We want to present a stable and secure increase for renewable energy source penetration. Through our research, we try to affect ongoing policy development. We tackle the problem of energy security, sustainability, and competitiveness. And as I said before, our main goal is to bring a solution that can provide access to the demand response markets and services to medium and small customers. Here you can see our solution in general. The Delta demand response framework introduces mainly 2 key innovations. The first is from the customer side. We have a fog-enabled intelligent device, and then we exploit virtual power plant principles, delivering a virtual data node, which is an aggregation of customers into creating larger entities that the aggregators can actually handle more optimally. So we want to relieve aggregators from resource-intensive tasks. We want to establish an automated, efficient DR management structure. This is both through the DDN and the FADES, the fog-enabled intelligent device. And of course, we introduce also 2 key platforms, the Delta blockchain and the customer services, which are both gamified and collaborative tools. Starting with the bottom-up approach, here you can see our hardware solution, which is deployed at the customer side. It's a lightweight unit that has a lot of software capabilities and a lot of different tools deployed on site. It has also hardware security embedded on the board, direct communication with multiple wired and wireless protocols, and of course interfaces for communication with smart meters or management system or energy management system directly. And since we want to target interoperability, we selected OpenEDR as the standard for being compliant with different platforms. Here you can see 2 very characteristic software components executed on site on FADE. We have adaptive load and forecasting engine, so each customer is responsible for presenting an accurate forecasting result with higher layers. And of course, we have cutting-edge flexibility estimation that combines both unsupervised and supervised machine learning models to extract flexibility without necessarily knowing a lot about the infrastructure of the client. Following, we have the Delta virtual node, which, as I said, we have aggregation of different kind of customers together, so that larger entities can participate even in current PR markets. So we have in adopting a multi-agent design, where each DVN, each virtual node is practically an agent that has additional intelligence. So we have a clustering engine that creates groups of customers to facilitate even more the optimization logic based on flexibility, availability, reliability, and even social characteristics. We provide two-step cross-validation for the forecasting, because, for example, if we lose communication with one of the customers, we need to be able to deliver an accurate forecast for the entire TDN without solely relying on the individual data. And of course, we have an intelligent optimal dispatch component, which also acts as a fail-safe mechanism for demand response. So this is one of the very few approaches out there where we actually monitor the demand response request in real-time operation, and in case there is a failure from a customer, either due to technical problems or if the customer does not want to deliver, then the DVNs communicate either internally or externally with other DVNs to identify a solution and deliver the initial request. Here you can see an example of this application. So we have a DVN with 25 customers, and you can see that one of the customers at 1511 didn't deliver what was expected. So 1 minute later, we have a resolution of 1 minute. We send the DVN tackles this by sending another event to other DVN. Whereas in 1521, we have the same problem, but the solution is found inside the DVN. So you can see multiple signals being generated to other customers so that the initial DR can be met. What we found by delivering this is that we have significantly faster execution times. We can achieve quite the profit margin, in some cases up to 3 orders of magnitude higher. We have more fair and balanced utilization of customers. And of course, as the node scales up, we have better results because, as you can understand, the clustering becomes more and more effective. Another interesting point is that the proposed schemes provide a 2-point tolerance system, which is 1 point more than current standards in the power system community. Now, on the higher level, we have the Delta aggregator, which is responsible for creating the nodes. So we have another segmentation process based on both static and dynamic information for creating the nodes. We have participation to market. So we in order to do that, we have engines for forecasting prices for day ahead, intraday, and imbalance market market in general. And we also have a tool for checking with the DSO the grid stability throughout the day in order to deliver PR optimization without creating problems to the network. So here you can see an example of the participation in the three markets. You can see the three different market prices and bids per market. As you can see, in some cases, the hourly bidding may be negative because either the forecasting engines didn't perform as they should, or the price deviated a lot from what was expected due to a problem. But also in cases where the aggregator wants to purchase energy for example, some energy storage system. However, throughout the day, we see that the aggregate profit is filing so that we can have a good revenue in the end of the day. We also tried to see what's the best balance between the incentive and the request. So we applied a reinforcement learning approach on our decision making at the aggregator level, and we showed that although we need a few days to learn, with in some cases significant losses in the first few days. In our case, it was the first 20-22 days. After a while, the system learns and performs in a stable manner, introducing a viable solution for business solution for the aggregator. On top of that, as I mentioned, security is a must for Delta. So we have created our permission blockchain. Every transaction is registered on the blockchain and is accessible from all parties. And to be able to introduce OpenADR related information within the Delta blockchain, we created related smart contracts. So we have an OpenADR smart contract which are used for the transactions in terms of the demand response requests. So either time of use tariffs or direct load control, OpenADR standard, are covered as specific smart contracts. Right now, we are in the process of evaluating and validating our solution to the pilots that we have. The first one is in UK, where we have both residential and commercial buildings, and the second is in Cyprus, the Cypriot pilot, where we have the entire University of Cyprus campus, as well as a pre-pilot lab testing in Greece, where we apply various scenarios to validate our prototypes. This was all in a nutshell about Delta and where we are right now. As we would like to also explore the potential and of our solution, we would like your opinion and your feedback. So we prepared questions in regard to market and products in the form of poll. I don't know, Zia, if you would like to do it now or in the end.
It's on the screen. Thanks. So if you can, we're collecting responses now. I'll give it about 10-15 more seconds.
Okay, that's great. So the first question has to do with the market, as I said. So we want to know which flexibility market role you think that has the highest potential for expansion in the upcoming years. Some of the solutions that we have identified are either product providers in the term of hardware or software solution, aggregators, flexibility traders, or even subcontractors like subcontractor to an energy retailer or microgrid manager providing demand response services. And the second question has to do with the perspective of products developed in the market, either through Horizon 2020 project or other entities. And we have identified mainly 5 main products that have to do with security services, user interfaces, technologies for aggregation, clustering, and in general, virtual power plants principles. Flexibility, which is one of the most important parts in demand response. Communication interoperability as the last one, but not least important. So these are all from my side. Zia, the floor is yours.